Hello everyone, my name is Sai Shreya Krishna and I am a master's student in data science and analytics at Grand Valley State University. Today I will present my analysis on depression using enhanced data focusing on the PHQ-9 screening tool. This work was completed under the guidance of Professor Kevin Maupin. He is my supervisor and I work as a research graduate assistant under this professor. In this presentation, I will explain how I used national survey data to understand the socio-economic and demographic factors associated with the depression. Let me start with my objective. The objective of my project is to analyze depression using PHQ-9 scores and identify the socio-economic and demographic factors that influence depression. My goal is not to build a predictive model, but to understand relationships between variables. To achieve this, I used regression analysis to study how factors like income, education, marital status, and gender are associated with the depression. To achieve this, I used enhanced dataset, which I will describe next. I used data from Enhanced 2017 to 2018 data, which is a nationally representative health survey conducted by the CDC. Enhanced collects detailed health and demographic information from participants across the United States. For this analysis, I used two datasets. The DPQJ data, which contains PHQ-9 depression questionnaire responses, and the demo J dataset, which contain demographic information. Like to find these datasets, or like if you are interested, you can navigate through this link. You will find these variables. Under these variables, you can find these datasets. And the common variable for both these datasets is SEQN, allowing me to combine health and demographic data for each participant. Before analysis, I performed data cleaning to ensure quality and consistency. Data cleaning was an important step in my analysis. For the PHQ-9 data, I handled float artifacts by converting them to 0. Since valid responses range from 0 to 3, I also replaced invalid responses, especially values 7 and 9, which indicate refused and don't know, with missing values. This ensured that the PHQ-9 scoring is accurate. For the demographic data, I renamed variables for clarity and removed variables with high level of missing data. After cleaning, I merged both datasets using SEQN, which is common identifier in both datasets, resulting in a final dataset of 5,533 participants and 40 variables with relevant variables. So after cleaning the data, I created key variables for analysis, which comes under feature engineering slide. So in the feature engineering step, I created key variables from the PHQ-9 data, questions, and the PHQ-9 consists of 9 questions measuring the depression symptoms. And in this step, like I computed a total PHQ-9 score by summing these 9 items, resulting in a score ranging from 0 to 27. So the PHQ-9 consists of 9 items labeled DPQ-010 and 2 DPQ-090, which measure the frequency of depression symptoms over the past 2 weeks. Based on standard clinical guidelines, I created a binary variable called probable depression. where a score of 10 or higher indicates depression. I also created a suicidal ideation variable using DPQ090, which specifically captured thoughts of self-harm. In addition, the dataset contains DPQ100, which measures how difficult these problems have made daily functioning. However, I did not include DPQ100 in the total score because it is not part of the standard PHQ-9 scoring. So I have included only from the DPQ10 to DPQ90. Instead, it is a functional impact measure, like which is DPQ100, and in including it would mix symptom severity with outcome impact. Therefore, I focused only on the 9 core PHQ-9 items for constructing the main variables. Next, I explored the data to understand overall patterns. I evaluated data completeness to ensure reliability. Most participants answered the PHQ-9 items. So most participants, like above 5,000 participants, almost above 5,000 participants answered all PHQ-9 items, which is good, which is really good. And so this indicates that the dataset is suitable for analysis and supports the validity of my results. And going to next slide, which is distribution and prevalence of depression. I explored the distribution of PHQ-9 scores. Most participants had lowest scores between 0 and 5, which is really good, like indicating minimal symptoms. Only a smaller proportion like showed high severity. I found the 461 participants met the criteria for the probable depression, which is about 8.33 percentage of the sample, like 8.33, 461 participants like depressed. Additionally, 192 participants reported suicidal ideation, around 3.5 percentage. These findings align with expected population patterns. So after exploring the data, I moved to weighted analysis to estimate population level results. Since NHANES uses a complex survey design, I applied sampling weights to estimate population level prevalence. I used the interview weight, which is WTINT2YR, after creating the analytic data set. Using these weights, I estimated the US population prevalence of depression to be approximately 7.9%. I think once you notice, before applying weights, it was 8.3. After applying weight, it is 7.9 percentage. I also observed important differences here. Have I have attached some plots here to reference. So this is income, like depression income plot. This is marital status depression, depression and sex, depression by education. So yeah, these are the plots, and you can see like we got 7.9 percentage of prevalence after applying the weight, and depression was higher among females, and individual like individuals with lower income faces like higher depression. This is low. Individuals with lower income faces higher depression, and with higher income faces lower depression. And those who separated or diverged also facing higher depression. And it was lower among college graduate students. These results show a clear socioeconomic gradient in depression. And going to next slide. To validate these patterns, I performed statistical testing. To confirm these patterns, I conducted chi-square tests. The results were statistically significant, indicating that depression varies across demographic and socioeconomic groups, where you can see the all p-values are small than smaller than 0.05. So you can say that like all results were statistically significant, indicating that the depression varies across demographic and socioeconomic groups. This supports the patterns observed in the descriptive analysis. And going to next slide, which is modeling approach. Next, I built regression models to understand the relationship between variables. And I used logistic regression to analyze relationship between predictors and depression. The outcome variable is probable depression. The predictors include age, gender, race, education, marital status, and income. I included age, gender, and race as control variables to adjust for confounding and ensure accurate interpretation of results. Why controls? I included control variables to avoid confounding effects. For example, age and gender can influence both income and depression. By controlling for these variables, I ensured that the effects of socioeconomic factors are estimated more accurately. So coming to Model 1 results. In Model 1, I included all variables in their original form. As you can see in this picture, I have kept all variables in their original form, and several race categories were not significant. So here p-values, almost all three of four race categories, race variables in like are not significant, more than 0.05. So, and age also is like 0.33, which is more than 0.05, which is not significant. However, gender and income were significant predictors. Some education and marital show categories, like one of the, for example, you can see like in marital status, one of these variables are not significant. So one of the variable is not significant, like that. Some of the variables in education and marital categories showed instability. Based on these findings, I retained age and race as control variables and decided to refine the model. Coming to Model 2 results. In Model 2, I grouped categories to improve model stability and interpretability. What I did was like which was not significant before, I grouped those variables in a particular category and kept the variables which are significant as separate variable. So for example, in race, I kept Hispanic, non-Hispanic, white as separate variable, and remaining variables I have like grouped as other, like that. So race, education, and marital status were simplified into fewer categories. The refined model showed clear results. Gender remained significant, with males having lower odds of depression. income showed a strong negative association, indicating the higher income reduces depression risk. Education and marital status also showed meaningful effects. The model has a pseudo R squared of approximately 0.048, indicating modest fit, which is typical for this type of data. Getting to know about key predictors from the model refined. From the final model, I identified key predictors of depression. Males have lower odds compared to females. Higher income is associated with the lowest depression risk. Married individuals have lower risk compared to divorced individuals. College graduates also show lower odds of depression. These findings highlight the importance of socioeconomic factors in the mental health. So finally, I would like to conclude my analysis. Using enhanced survey data, I estimated that the weight prevalence of the depression in the US population is approximately 7.9%. This reflects a realistic population level estimate after accounting for the survey design. Overall, the results from my analysis are consistent with real world patterns as expected, like in reality, which increases confidence in the findings. I found that the socioeconomic factors play a major role in depression. In particular, income, education, and marital status emerged as key factors influencing depression outcomes. More specifically, individuals with lower income, lower education levels, and those who are not married tended to have a higher risk of depression. This highlights an important pattern in this data where depression is more common among socially and economically disadvantaged groups. In other words, there is a clear socioeconomic gradient in depression, meaning that as a socioeconomic status decreases, the likelihood of depression increases. Overall, the analysis demonstrates the depression is not evenly distributed across the population but is strongly influenced by underlying socio and economic conditions. And I want to conclude with my limitations. Like, there are some limitations to this study. Although I used weights for prevalence estimation, the regression model itself was unweighted, meaning it does not fully account for the enhanced survey design. The data is cross-functional, so causal relationships cannot be established. Additionally, there may be unmeasured factors influencing depression. In future work, I plan to use the survey weighted regression methods such as SVYGLM to improve the analysis. So overall, this analysis highlights the importance of socio-economic factors in understanding depression at the population level. Thank you.